Hello dear users of digital photogrammetric workstation PHOTOMOD. We are continuing a series of video tutorials dedicated to working with PHOTOMOD 6. I want to remember you that in two videos before we considered questions of installing program, data storage management in resources system, creating project and adding images to it. The subject of today's training is an internal orientation of images and a construction of block layout. The internal orientation of images is performed for calculation of parameters defining a position of image coordinate system relatively digital pictures coordinate system. In other words, in a monitor display. A block layout is an approximate terrain scheme obtained by coinciding images on neighboring overlapping areas. In the context of today's training, we will analyze creating a block layout on the basis of exterior orientation data. Firstly, let's start PHOTOMOD and open previously created project Allen. The first thing that should be done after adding images to the project is to create camera file and perform an internal orientation of images. For providing more comfortable access to tools we need, I recommend you to open corresponding toolbar. Window, Toolbars, AT. I click on Manage Project Cameras and create new camera. Now all fields of opened window should be filled in accordance with calibration certificate of camera. This certificate looks like this. As you can see, our survey was done by Digital Camera DMC. Digital camera parameters in millimeters, focal length of camera is about 0.12 meters or 120 millimeters. Coordinates of principal point 0 for x and 0 for y. Point of origin is an image center. Pixel size 12 micron in X and 12 micron in Y. Sensor size is optional parameter. If sensor size is defined, it's possible to recalculate the position of the principal point while changing a point of origin. You can see that coordinates of principal point was changed. But like I said before, sensor size is optional parameter and we need not to use it right now. Given camera has not a distortion, but if it's necessary, you may input parameters of distortion with 5 various ways, using formula, radial distortion, 4 directions of distortion, or 8 directions of distortion, depending on the format of distortion in calibration certificate of camera you have. Click OK. Camera is created. Now I selected all images in the list and assign selected camera to selected images. Execute. Next, it's necessary to set rotation of camera axis. Firstly, let's select 0 degrees and check a correctness of this value of rotation. Since kappa angle, which defines plane's heading, is read out from x-axis should coincide with the flight direction. Let me to zoom in and images. In this field, I do it with help of start button from my keyboard. And now, while sequential pictures changing from 112 to 116 and from 46 to 50, we set that x-axis coincides with the flight direction. It means we have set camera rotation correctly. Of course, there are cases when rotation of camera axis can differ from 0 degrees and furthermore can be different for images in different strips, but it's a subject of separate talking. After completing internal orientation, sign plus will appear in column internal orientation next to each image. Press close. One of the important data sources for forming a block layout is exterior orientation parameters of images. File with exterior orientation data looks like this. It includes coordinates of projection centers and 3 angles of images rotation. Exterior orientation file is recorded by GPC IMU device while surveying. Now let's load this file into PHOTOMOD project, orientation, import exterior orientation. I'm searching my exterior orientation file and open it. I pay your attention that this file should be in TXT, CSV or Part B format. Line template is set in the bottom part of the window. In my case, it contains projection centers and angles omega, phi, kappa. Field separator in source file is a comma. Decimal separator is a point. If image names in the project don't fully match image names in the exterior orientation file, it can be taken into account while importing exterior orientation data. I activate this option. If there aren't any image names in exterior orientation file, but its sequence corresponds to sequence of images in the project, it's possible to match them by a record number. If it's necessary, I may activate this option, match by record number. If default sequence of column names in fact does not match its content, you can change it with moving names from available fields area. In a such way, for example. Since the first line in the list contains columns names, we should start import from the second line. Next. Measurement units of angles are degrees. Projection centers precision and angles precision should be set in accordance with an accuracy of which defined by GPS IMU device. In our case, it's 50 centimeters for projection centers and 0.01 degrees. Minimum and maximum heights fields are filled from properties window that we set while creating project. Let's see what will happen if we set maximum height of the terrain more than maximum height of projection centers. Maximum height of projection centers is about 1190. So let's input 1200 meters for maximum relief elevation. Press next. On the third step of import, I can do additional actions. Split block into strips by exterior orientation data, create block layout on the base of it, and rotate images in block scheme by block layout. If an accuracy of exterior orientation data is rather high, it's possible to adjust block without measuring ground control and tie points. Execute. Split images into strips from the top to the bottom and from the left to the right. OK. As you see, images are splitted by two strips, but their mutual interstrip position is not correct. It's caused by wrong set of relief elevation. Let's import exterior orientation file once again with right values of minimum and maximum terrain heights. $550 meters. Now everything is OK and our block layout is formed. So we have finished internal orientation of images, we have created camera and assigned it to images, loaded exterior orientation data and constructed a block layout on the base of them.